Hello everyone, this is Sangeeta, Assistant Professor, ECE Department, SNS College of Technology. So the today topic is weighted resistor DAC. So let us have a small recap about what is DAC and what are the different types of DAC. And the DAC is digital to analog converter. It is the one of the application of operational amplifier. We know what is operational amplifier. The operational amplifier is the amplifier which amplifies the signal applied between its non-inverting and inverting terminal. And coming to DAC, DAC is digital to analog converter. It is mainly used in analog that is audio systems and communication systems. There are two types of DAC. The one is weighted resistor DAC and another one is R2 or ladder network. And the main parameters are accuracy, resolution and linearity. Let us move on to the topic. The first slide is empathy. That is, empathy means the requirement of the this product. Why we need a DAC. So it converts digital to analog signals, and also it gives different output levels for different binary inputs. It is very easy to design and very simple to design. The main application is audio and signal generation circuits, process control circuits, and it is mainly used to control actuators and valves in process control systems. Also, it helps the digital systems to control the real world analog devices like actuators, motors. And the next one is define. So considering all these points, we can define what is weighted resistor DAC. So the weighted resistor DAC produces an analog output which is almost equal to the binary input. That is the digital input by using binary weighted resistors in the inverting adder. Here this is the operational amplifier, this is the inverting terminal, and this is the non-inverting terminal. In the inverting terminal, this is the resistor network connected, and here the network that is the resistor weighted resistor value is 2 power 0, and this is 2 power 1, and here 2 power 2. That is why it is called weighted. So in the first leg, the resistor value is 2R, and in the second leg, that is 1R, and the second leg is 2R, and like that the fourth leg is 2 power 2. That is the binary weighted resistors. So it is connected to the inverting adder circuit. In short, binary weighted resistor DAC is called weighted resistor DAC. So here, so the binary bits of a binary number can have only one that is values, that is either 0 or 1. So let us have a three. For example, if we have a three binary input, so the circuit is mainly designed for three binary inputs, that is B2, B1 and B0. So the bit 2 and bit 0 is denoted as, that is bit 0 is denoted as most significant bit MSB, and the least significant bit is called, that is bit 0 is least significant bit. The digital switches are used here. The SPST switch is used. That is the main working of a circuit is, suppose for example, if the binary values are 1 0 0. So 1 is the MSB bit and 0 is the LSB bit, and center value is also 0. So the first leg, that is LSB bit, is connected to ground, and the next bit is, that is B1 is also connected to the ground, and the MSB bit B2 is connected to the reference voltage. This is the main working. And according to the virtual short circuit, the voltage at the input, that is inverting input terminal of the operational amplifier is same, that is equal to the voltage present at the non-inverting input terminal. So the voltage at the inverting input terminals node will be 0 volts. And this is the nodal equation. So the equation represents the output voltage equation of 3-bit binary weighted resistor DAC. The 7 possible values of output voltage by varying the binary value from 000 to 111. For a fixed voltage reference, here we are using the reference voltage level. Okay, and this is the nodal equation, and the first leg is 0 plus VR, that is a reference voltage B2 divided to 2 power 0 into R, and V0 B1 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 for B1 the equivalent resistor value is 2 power 1 R, and 0 plus VR B0 divided by 2 power 2 R plus 0 minus output. This is the output. This is the output, and V0 is equal to 0. After simplifying this, we will get VO is equal to VR into RF, that is divided by R into B2 divided by 2 power 0, B1 divided by 2 power 1, and B0 divided by 2 power 2. If the values of all the R is equal to 2 power RF, then the output voltage is equal to VR divided by 2 into B2 divided by 2 power 0, B1 divided by 2 power 1, and B0 divided by 2 power 2. So this is the final nodal equation. The generalized output voltage equation is VR divided by 2 into B power n minus 1 into 2 power 0, B n minus 2 divided by 2 power 1, up to we can use up to the different binary values. So this is the working of weighted resistor network, and the main disadvantage of weighted resistor network is here we are using different for 3 values we use 2 power 2, that is 4 OR values. If we increase the number of bits, it is very difficult to get the resistor values. It is very difficult to design more accurate resistors as the number of bits present in the digital input increases. So this is the main disadvantage of the weighted resistor network. Hope this video will help you to understand what is DAC and what are the different types of DAC and what is a weighted resistor DAC. So this is the assessment time, and the question is what is meant by weighted resistor DAC and what is the main disadvantage of weighted resistor DAC. So in the next class submit your answer.